let's go to the AutoCAD. Let me share the screen. Wow. Okay, can you guys see my screen now? Can you see the AutoCAD interface?
You can see your screen.
Yeah.
Yes.
Okay, so what we calculated, because what you normally represent on the floor, on your ground floor plan, is the going, not the riser. What you represent when you are looking at your building from the top, what we'll be seeing is the going, not the riser. So we calculated the total length for the riser, for the going, to be 3 meters, right? So let's take the measurement of this place. Let's see where we can, what we have. So if you have from here to this place, so we have that to be 5,000 something. Then this minus the 3 meter, we'll be having about 2,000 something. Then when you divide it by 2, when you have 3,000, let me pick my calculator. Let me pick my calculator so that I'll be giving what I have, the values I have here. I don't want to go back to share the screen again. I have 5,995 minus 3 meter. That will give me about 2,995. So I want to now get the width of the landing. I'll do divided by 2. I'll have about 1 point, that is 1495. 1495. So that is kind of too big for me to use, right? We can actually do something what we call now. I can actually extend this beam to be the support of my staircase. Okay. I can actually extend this one now. So this will now be this will now be the support of the staircase. This is a beam. The beam that supports a staircase is called a stringer beam. A stringer beam, that is STRINGER, a stringer beam. That is a beam that supports a staircase. So if I take from this place now, the measurement for here to this place, let's see what we have. We have about 3,913, okay? Can you guys still see my screen? Can you guys still hear me?
We can hear you loud and clear.
Yeah, we can hear you.
We
can hear you.
Okay. Any question both of what I've said so far? Any question? Is there any way you're confused? Let's see.
Please carry on.
All right. Okay, so why I brought out the beam, I want this beam to carry my staircase. So this is called a stringer beam, like I said last time. So I'll have my landing at this place, okay? Remember what we measured, we have about 3,913, and the total length of our going is 3,000. So my landing will take 913. The width of my landing will be 913. So I'll make an offset of 913. I'll make an offset of 913. 913. So this is now the width of my landing. Then what I have from this place now to this place becomes is 3 meters. So that's the total length of the going. So what will now be the width of the staircase? Let's see the dimension of this column here. The center of this one to the center of this. Sorry for the disturbance. So the total width is 1800. So I have to make a space between staircases. So let's take about 100 mm. 100 mm. So 1800 minus 100 will give you 17. 17 divided by 2. 17 divided by 2. Divided by 2. That will give you 850. So I have to offset this line from here to this place 850. Offset from here to here 850. So make an offset of 850. An offset of 850. Then from here, so let's trim the unwanted lines. Trim the unwanted lines. In your staircase, you only have between the two flights. So that is what we actually created here. So 850 is your width of the staircase. Then this is also the width of the staircase. So then we have the size of the going to be 300. So we'll make an offset of 300. We'll make an offset of 300. Enter. So I pick this line. Let me trim this so that I don't have to trim much. Let me trim this now. So I don't have to trim much. Okay. So let's continue making the offsets until we make about 10 offsets. So this is the first one, the second one, the third one, the fourth one, fifth one, the sixth one, the seventh one, the eighth, this is the ninth one. Then the 10th one will be on the beam, which is okay because the beam is actually what is carrying the staircase. Okay, and let's make a copy of this. Make a copy of this. Okay. Can equally. Okay. Sorry, I need to trim this. I didn't actually trim. Okay. So I need to trim this for trim. Select the boundary. And to trim all at once. Okay. So we'll now make a copy of it and place at the other side. We'll copy. Okay. And we are done placing the staircase. We are done placing in this staircase. So can you guys still hear me? Any question about this? Can you guys still hear me?
Hear you, sir. Carry on. We can hear you. Carry on. Carry on.
Yeah, I can hear you. I can hear you.
Yeah, I can hear you.
Can you guys still hear me? I think I'm having
Yes.
network.
No, we can hear. We
And
can
my
hear
screen.
you.
Carry on.
Carry on.
Okay. Any question based on what we just did now? Any question?
Yes, sir.
Okay. So basically, what we just did is we tried to place the staircase, and we used a minimum size of the going to be 300, which is from this place down to this place is 300. Like I said, when you're looking at your building from the top, what you'll be seeing is the not riser. So this line now you are seeing represents the risers. It represents the risers. So from here to this place here now, the total is 3 meters like we calculated. And this staircase is being supported by this beam. So this beam is now called a trigger beam. Okay. Then from here now we formed, we have seen another slab here. Because once you come up from the staircase, this is where you will find yourself. So this is also a two-way slab. This is also a two-way slab. So I will copy this to paste to show the nomenclature for the slab. So we can now drop this here. This is actually slab. So like I said, in slabs, this is called panels. They are called panels. That's this letter you are seeing, P1, P2. So the next now is to give these panels numbers. To give them the panels numbers, I'm going to start by selecting this text to change the numbers. We'll select them to change the numbers. And this is how a one-way slab is represented. This is how a one-way slab is represented. Okay. So then you come down to this place, under this text, you see content. Click on this. Then there's a small arrow here or an icon. You click on this. When you click on this, some dialog box will pop up. Something like this will now come up. I don't know if you can see this. Can you guys actually see this? So once you click on this, after you have selected the multiple text, then you come to this text. Under the text, you have a content. You click on the content, you have this small icon. You click on this, then you can now start changing the numbers. After that, the other one I didn't select is P1, so this one will be P2. I'll click outside. Then another one pops up again. So we keep doing this thing too. We change the numbers of the panel. This P3, P4, P5, P6, P7, P8, P9, P10, P11, that's panel 11, panel 12. So I think, okay, we have, well, the total panels we have is 12 in number. So on placing the slab, the next now is to place your beams. So I'll be sharing a screen now. Something. I'll be sharing a screen now for us to explain something. Okay. I'll be sharing a screen. Okay. Can you see the new screen now? Can you guys see the new screen?
Can you zoom it? Can you zoom it?
Yes, we can actually see
Let me
it.
zoom in. Okay, is it okay now?
Much better.
Yes.
Okay, this is much better. I hope you can see what is in the picture. So what you have here
Yeah.
is
Okay.
okay. So what you have here is a T-beam. A T-beam. This is your. If you guys should follow this pointer, please, so that you're able to follow what I'm explaining. So what we have here is a T-beam. This is a section of a T-beam. Then, and these circles or these shaded circles is your reinforcement. This is the reinforcement. This is the top reinforcement. This is the bottom reinforcement. Then this kind of something that looks like a loop around it is called the links. This is the links that ties the reinforcements together. This is what we call the links. Okay. So what we want to get here now, we want to get the initial size of sectioning of the beam, which is called the depth of the beam. The depth of the beam. So the depth of the beam from this diagram, from the top of this down to this place, is called the depth of the beam. Then from here down to the center of the bottom reinforcement is called the effective depth. It's called effective depth. So for you to get the initial size or the thickness or the depth of the beam, the formula is given as the effective depth
Please, can you
plus.
come again, please? I'm sorry. I'm sorry for interrupting.
Okay, no problem. Okay. So I said what we are seeing at this picture, if you follow my pointer to follow what I'm explaining. What we are seeing here is a section of a T-beam. And these shaded circles we are seeing, these small circles we are seeing, is called the reinforcement. That is, or rebars. This is a top reinforcement. This is a bottom reinforcement. Then this something that goes around it. This something that goes around this is called the links. The links that ties the reinforcement together. Okay. So what we want to get now is to get the thickness or the initial size or initial thickness of the beam. That's what we want to get. So once we get that, we're able to represent that in our general arrangement. From the diagram, you can see that from the top of this place down to the bottom of this is called the depth of the beam. It's called the depth of the beam, which is represented as H. Then from the top to the center of the bottom reinforcement, is called the effective depth. It's called the effective depth. So for you to get the thickness of the beam, it will have to be the effective depth, which is this D you are seeing, plus, remember this top at the center of this reinforcement. So the remaining will be the bottom reinforcement, that is the diameter of the bottom reinforcement divided by 2, plus the diameter of these links you are seeing, plus the concrete cover. So the minimum for a beam, some people take 20, depending on the exposure of the beam. in a residential building, most people take 20. So, but we are going to assume 25 for our concrete cover. So we're going to assume 25 as our concrete cover. So the next one is, how do you now get this your effective depth? The effective depth is given by the length of the beam over span to depth ratio. Span to depth ratio. This L over D is called span to depth ratio. In your BS 8110, it is there that when you have a cantilever, the span to depth ratio is given as 6. When you have a simply supported beam, it's have as 12. And when you have a continuous beam, you have that as 15. With this information now, that is what we are going to get the initial size of our beam. So I hope you guys understand what is in the picture now. Do you guys understand what I've explained so far? Please unmute yourself and talk. Okay. So let's go back to the AutoCAD now. Let's go back to the AutoCAD. I want to share the screen now. Okay. I hope my screen is on now. I hope the AutoCAD screen is on now.
Yes, we can see it.
Yes, we can see it.
Okay. So, what are the types of beam we have here? What are the types of beam we have here? From what we can see, from this place down to this place, this is a continuous beam. This is a continuous beam. Then, likewise, this one. So, almost all of them are continuous. Almost all of them are continuous. So, most engineers use 450 mm as the depth of the beam. But in Nigeria, they said the minimum should be 400. The minimum of your beam should be, the depth of your beam should be 400. So, but most people use 450 to be on the safer side. So, let's now get the size or the initial depth of our beam. To get the initial depth this of our beam. Okay, so this is, remember, this is a continuous beam. So we're not going to take the stake of taking the whole length. So what we're going to be doing is, can you guys still hear me?
Yes.
Can you guys still hear me?
Yes, we can.
Yes.
All right. So don't make the mistake of taking the whole length, because this is a continuous beam. If I want to take the whole length, please don't do that. So take your length, column to center of the column to the center of the column, center of the column to the center of the column. From the formula we have, we know that the effective depth is given by L over span to depth ratio. So the length here will be 3113 from what you are seeing here, what you are seeing on the screen, divided by the span to depth ratio. So what type of beam do we have? We have continuous beam, and in the BS 8110, we are giving that to be continuous to be 15. For a continuous beam, so we divide by 15. We have 207 point something plus your bottom, the diameter of your bottom reinforcement divided by 2. So in Nigeria, the minimum for a beam is 12 mm. It's 12 mm. So let's take that. Let's take 12 mm. So 12 divided by 2 will be 6. So it will be 207.353 plus 6. Then your link's diameter, the minimum is 8 mm. 8 mm for the link's diameter. So we are going to be using 8. So plus 8. Then your concrete cover, we'll be using 25 plus 25. So we're having that to be 246. You have that to be 246. So even when you use 400 as the depth of your beam, it still carries your structure. So, but we are going to make that assumption of we're going to take 450, since it's what everybody use to us to be on the safer side. So we make use of 450 as our depth of our beam. So the width of the beam, you always take the size of the walls. So this one is going to take a size of 225. We'll be taking a size of 225. Then we will now try to represent them. So I'll click on text. I will have the depth as 450 by 225 beam O1. Okay. We can use the text height under the text to get to the text height here. Let's take a text height of 250. Enter. Okay. So we are using the worst case condition. The longest beam. Then you really choose your size of sectioning. Once you make that size of, then you use it for the whole beam. So this, I think the longest should be this one here. So I think this is the longest. So, but once you use this one too, you have to fall between this 450. So we fall within this 450. So we're going to be using 450 as a depth for all the whole beam here. So can equally copy this. Copy this down here. I need to rotate to make one vertical for my placing. Okay. So we can now copy this and start placing on the beams. Okay. So for that, remove this column to column dimension. Remove the column to column dimension. Oh, you guys can still hear me?
Yes.
Okay. So start copying to our beams. Okay. So this one text will be for this continuous beam. This one will be for the continuous beam. So let me place the horizontal beams first. Then this is for this one. Okay. I think let me do that because I have to reduce the size of that one. So let me start placing for the big ones before the small ones now. So we'll place for this one. Place for this. We place for this one. We place for this. Let me reduce the size of this one. Make this 200. Let's make this 100. Let's test it for the small beams. Okay. This should be okay. But it is your choice how you want your text size to be. You can actually reduce that to fit in to make it look neat. So actually, I don't have time to start reducing the size to make it look neat. So when you're doing yours, you can try to reduce the size to actually make it neater. Okay. So we can now start placing for the horizontal. Now start placing for the horizontal. Sorry for the bar, not the horizontal. So for this one here, can place for this one. So like I said, when you're doing your own, make sure you reduce the text size to neat. So, but I don't think we have time to make it look neat. Right. So we have this here for this one. Remember that this one I placed here is for this beam, because this is being continued from here down here. This also is for this one. Then you cannot place for this one too. Cannot place for this. So I think we are not placing the beams. No one left out. No one left out. Let me see if I reduce the size of this one. It's too big. Let's make it 200. Okay, this should be okay. Okay. Let's see if we can reduce the size of this too. Let's make it 180. Should be smaller. Okay. So we are done placing the beams. Then let's go to the roof general arrangement. This is the roof general arrangement. This is your first floor general arrangement. Like I said yesterday, that your ground floor will be used to generate the first floor general arrangement, while your first floor plan will be used to generate the roof general arrangement. But in case you have maybe a continuous story building, ground floor for first floor general arrangement, first floor for the second floor general arrangement, second floor plan for third floor general arrangement, and it continues in that way. So this is our roof general arrangement. What we have is a pitch roof. That is your hip roof, or this normal common roof you see around. So the dead load and the live load, the total should be 2.5, 2.5 kilonewton per meter. Uniformly distributed, 2.5 if I'm correct. So because of that, I will possible for me to remove this here, because it's only carrying the roof. It's not carrying much load, so I can actually remove this one. I can actually remove this secondary beams here. I can actually remove the secondary beams. Since the load from the roof is not much, we can remove these ones now. So we have this as our roof beams. So make a copy. Move this to this place. I hope you guys are still with me, or am I disconnected?
We are
Hope you guys are still
No,
with
we're
me.
still with you. Yeah.
Okay. So, since it's a roof beam, it's carrying only the roof. It's a very small load. It's not that it's very small, but it's compared to other ones. So we can actually reduce this depth of the beam to 300. We can actually reduce it to be 300 because it's a roof beam. Okay. So I'll make a copy of this and start placing them. This for this one, this for this, and this one for this one, this one for this. Okay, we are done placing the horizontal beams. Then let me rotate this to place the vertical ones. I'll rotate this now. Make a copy. Start placing them. This is for this one. This is for this. Then this is for this. Okay. So we are done placing the beams. So like I said, we have beam O1, so we have beam O2, beam O3. So I want to start using the beam numbers. So I will highlight all of it. I'll highlight and begin to change the names. Like I said, now I have time to be placing the text in a proper way so that it will look neat. But if you are working on your own, make sure you make it look neat. And make sure you place the text well so that they won't have to interfere with each other. Make sure you place them well so that anybody that have what you done or what you have designed should be able to read it well without asking you what is this and all that. That's one of the goals of your design. Somebody who is reading your design should be able to understand without much question. It's not that the person shouldn't ask questions, but shouldn't be more questions. It could be little question. So right. I'll come to this same under this text content, click this small icon, and I can start changing the numbers. This is 1, so the next is 2. So beam O3, beam O4, beam O5, beam O6, beam O7, beam O8, beam O9, beam 10. That is the number of beams you have. The number of beams you have. Beam 11. We have beam 12. Beam 13. We have beam 14. Beam 15. Beam 16. Seventeen. Beam 18. Beam 19. Beam 20. Beam 21. Beam 22. '24. And beam 25. Okay, we are done changing the number of beams. I can actually do this one. Let me have space. So I hope you guys are still with me. Let's move. Are you guys still with me?
Yeah, we are still with you.
Okay. So from what we can see here now is
yes, we are still with you.
Okay. So from what we can see here now, we see that we have a beam that carries a slab, and we have a beam that doesn't carry a slab. So this one is carrying the slab, and this one is not carrying a slab. So there's a nomenclature to represent the beams that are actually carrying slab and the ones that are not carrying slab. So from your engineering drawing, you know that anything hidden or anything under something will be represented with a dot line. Dot line. I don't know if you still remember in engineering drawing. The way to, the lines, the type of line used to represent something hidden is by using a hidden line. Because the hidden line is represented by a dot line. So we use a dot line to represent a beam that is actually carrying a slab. So I want to get that hidden line. Hidden line. Okay, this is the hidden line. So make use of this one. Okay, load. Okay. So this one's actually carrying the slab. Will be represented with a hidden line. Remember, these ones are outside, so it will be left as a thick line. But this one inside are actually carrying slabs. So we're going to represent this one with a hidden line. Okay, so we don't want to waste some time to represent all of them. And this one to represent the hidden line. This will also be represented with a hidden line. This one. And this one with a hidden line. But this one, the staircase, we left as a line because when you are going up, you have your staircase is not covered by any slab. So that is why these ones will not be represented with a hidden line. So don't want to waste much time trying to represent all of it. So I just want to show you an example. So once I've selected, I'll come to this place, click on this hidden line, then change the line type scheme because it's not showing well. Let me increase to 20 and see what we have. Increase it to 20. Okay, and think it's coming up. Let me increase again to 40. Okay, so this is okay. So as you can see, this is where you present a beam. Once we are given a general arrangement plan, and you see that with a dotted line, it means that the beam is actually carrying a slab. But this one will be left like this with a solid line because it's not actually carrying a slab. Alright. So how do you now represent a secondary beam? Like when you see a secondary beam in a general arrangement, how do you know that this is actually a secondary beam? So we're going to represent these secondary beams. I'll show you how to represent them. Let me get rid of this one. Delete. Hope you guys are still with me.
Yeah. Yes.
Okay, so let's now represent a secondary beam. So I will trim this here. Trim and trim. So as I see, this is how we represent a secondary. Somebody seen this, an engineer seen this, so that this beam is resting on this beam. Okay. The same way, look at this one too. is already represented as a secondary beam. Once each one is resting on these two beams, you can also do that here. You trim this. Okay, I think we need to do that one direct. So that is how you represent a secondary beam. Present a secondary beam. So this one, the trigger beam, that is the beam that's carrying the staircase. That is secondary at this end. This is supported by a column here and then supported by the beam at the other end. By the other end. So let's now add let's now label the columns. Let's label the columns. Let's label the columns. Click on text. Label that C1. Enter. Click out. Highlight them as you select them, and come to this place to increase your text height. You can leave it to 250. Enter. Okay, I think this is okay now. This is okay. Let's see if we can change the color. Let's see if we can change the color to yellow. Yeah, let's make use of the one. So copy them. Start by clicking. So we'll try to add text to the column. Try to name the column. Like I said, we don't have time to resize or begin to move the text so that they won't interfere. But when you are drawing your own, make sure you make it look neat. Don't allow the text to actually interfere with one another. I decided to place this one here. On the side to place this here. Okay. So make sure your own is very neat, because if I'm working, I won't leave it as rough as this. I won't leave it as rough as this. Okay. Yeah. We are done placing them. Well, let's change the numbers. Let's give it different numbers, like column 1, column 2. So I'll select them. I want to number them. Select that how I want to them. Okay. So we come under the text, click on the content, click on this icon, changing the numbers. Okay, we have this one. So change it to column 2, click outside. Column 3, we click outside. Column 4, we click outside. And this picture I'm using, like, you select multiple text and try to change everything at once. I think the feature is available from AutoCAD 2017. I don't know if it's available on AutoCAD 2015, but the feature is available in 2017. So I don't know the version of AutoCAD they are using. In case you couldn't find this feature in AutoCAD, that means the version you are using does not support it. This is column 10, column 11, column 12, column 13, column 14, column 15, column 16, column 17, and column 18. So we copy to the roof general arrangement. Okay, let's copy this one. So it depends on you actually. You can decide to label this column from 1 to 18, continue from here to be 19, 20, all that. Or how I want to label this in those columns that started from the ground floor to the roof level, I'll give them the same name. Like this one now, this column 1, it is the same column 1 here because it continued from here to the roof level. And the column you have started from the ground floor to the roof level. So I'm going to use the same name I use here for this same here. So in case you have a case where your column stopped at the first floor, you can decide to use a different naming. So it's less for you to make such choice. Okay. I think we are done for this. We are done for the general arrangement. We have looked at how to convert your uh, architectural drawing to the structural drawing. We look at how to place your rooms. We look at how to place your slab, the nomenclature for two-way and which one is one way, how to know which one is two-way, how to get the thickness of the slab. We look at how to get the depth of your beam and the nomenclature for beams that are actually carrying slab and the ones that are not actually carrying slab. Yeah, and we look at how to place the staircase, where you have a staircase being supported by a beam, which is called a trigger beam. And that is all for the general arrangement. So what we need to do last now is to dimension your grid line. So I'll just do some bit of it. So what we just need is to dimension from this grid to the next grid. So that's what we're going to do now. So come to the annotate, continue, and keep dimensioning from from the grid line to the grid line. This will help in the placement of column, both on site and when you are using the proto structure. Because without your grid line, you won't be able to place the column on proto structure. So you just need to. This is a structural grid. The structural grid. So, and that is how you can continue until you get to this place. Then from here to this place. When you don't dimension again because it's already dimension up, you see the same thing now. When you dimension this place, you don't need to dimension this side because you see the same thing. You come to this place also, dimension here, you see the same thing. Then let's add some text of how you can actually represent the structural grid. I'll make a circle. Make a circle. Add the text. Okay, you make it of one. Down. Highlight. This is the text height to 250. Enter. Escape. Let me actually make a circle that is of this size. Let me click here and begin to expand. This is okay. Delete this and make a copy of this. So I need to get it at the quadrant. You come to this place under the snap cursor, click here, check on quadrant. You check on the quadrant, look out, then come close. You see this symbol here. So this is the point I want to actually pick from. Okay, start placing this. Start placing. Start placing. Start placing all of this. Okay, so I want to make use of 1, 2, 3. I can now come there to change the numbers. Come to the content, click on this icon. Okay, I didn't select that one, so we'll start from 3. Click on 4. 5. 6. 7. 'Okay, escape. Come to this. Double click. So I'll make a copy of this one now. Click here. And paste here. So this is now read as your grid 1, grid 1, 2, 2. Then for this one, I will repeat the same thing, but change the letter to A, B, C, D. So this will be AA, and this will be 1, 1. So the same process, the same thing you did here is what you will do as place. And that is end of the class. In case you have any question, please unmute yourself and speak. Thank you. Hello guys. Can you guys hear me? In case of any question, please can you
Yes, yes, we can
unmute
hear you.
yourself?
I hear you. I see you. I see with you.
We have come to the end of the general arrangement. Any question? Is there any question?
No, no, I don't have question.
Okay. Okay. In the absence of no question, then we call this a day. Thank you for your time. Have a beautiful sleep. Thank you.